So, good morning to all. Now, let us start the next lesson, optics. Now, in optics, many topics has been deleted from your syllabus. So, please check it out. It is already given to you. Refraction, which you have studied in class 10 also, that has been deleted from class 12th. You know that mirror reflects, you know the laws of reflection, the mirror formula 1 upon f is equal to 1 upon v plus 1 upon u, that all has been deleted from your syllabus of class 12th. Now let us start with the laws of refraction of light. You know that what is refraction? The phenomenon in which the ray of light changes its path when it travels from one medium to another is known as the reflection of light. Now, in this diagram, it is clear that when the light incidence from one medium to another, if it is the perpendicular, the light is coming from the rarer medium, and if it is going to the denser medium, it bends towards the normal. This already you have studied in class 10th also. Now, in case of when the light ray travel from rare to denser medium, it bends towards the normal, and if it moves from denser to rare medium, it bends away from the normal. Now, two rays of the light changes its path because its speed is different in different medium. Now, speed of light is different in different medium. So that is why it is changing its path. Now, absolute refractive index of any medium is given by n is equal to c upon v, where n is the symbol for the refractive index. So n is equal to c upon v, where c is the velocity of light in vacuum and v is velocity of light in medium. Now, refractive index or the relative refractive index means, relative means when you are finding the refractive index of any one medium with respect to any other medium. So this is represented as n2 upon n1, or we can write it as n to 1, or we can write is n2 with respect to 1. So this is the representation of relative refractive index in the either of the three manner. Either you can write n2 upon n1, that is relative refractive index of second medium with respect to 1. You can write it n21, or you can represent it as n2 with respect to 1, where n2 is the refractive index of the second medium, n1 is the refractive index of the first medium. Now, relative refractive index of the second medium with respect to the first medium. So now you know that n2 is equal to c upon v2. अभी जो से पिछली वाली स्लाइड में n is equal to c upon v, so we can say n2 is equal to c upon v2, or n1 is equal to c upon v1. From here, n2 upon v1 is equal to v1 upon v2, means the ratio of the refractive index of the two medium is the inversely proportional to the velocity of light in that medium. N is inversely proportional to the velocity of light. So in optically denser medium, the speed of light is smaller and vice versa. Now, here listen carefully, the word optical denser medium. It is not the mass density, it is the optical density. Now, optical density and mass per unit volume density are two different terms. Turpentine oil is optically denser than the water, but its mass per unit volume density is lesser than volume. You know that turpentine oil always flow over the water, so it is lighter than water only with respect to its mass density, but optically turpentine oil is denser than water. Now, frequency of light do not change when the light changes its medium. Now this is very important point, that frequency of the light does not changes when the light travels from one medium to another. Its only velocity or its wavelength changes. Now as we know that relation n is equal to c upon v, and in terms of wavelength, if we say that, then because velocity is equal to v is equal to n lambda, this you have studied in your ninth class also, that v is equal to n lambda. So in place of v we can write v is equal to n lambda, and in place of c we can write also n. Here n is the frequency, v is equal to nu lambda. In ninth class you have represented the frequency by letter n, so don't confuse it with the refractive index and the frequency. So v is equal to nu lambda. So in place of c, if we are writing c, then we can write nu lambda, lambda in vacuum, and v is nu lambda into medium. So v nu frequency remains same, so n is equal to lambda upon lambda medium. Now we conclude that the light changes its wavelength as well as its speed. Its frequency remains constant. Now you know that according to laws of refractions, two laws of reflections you have already studied in class 10th. According to the laws of reflection, then sine of I upon sine of R is equal to constant. I is the angle of incidence and R is the angle of refraction, and constant, this constant is the refractive index of that first medium with respect to the refractive index of the second medium with respect to 1. So that can be represented as n2 upon n1. So we can write n2 sine 1 I is equal to n2 sine n1 sine I is equal to n2 sine R. This is the Snell's law of reflection. The normal incident ray and refractive index the normal incident ray and the refractive ray always lies in the same plane. Now principle of reversibility of light means, now if the light is traveling from one medium to another, and if some mirror is placed on that medium like this, let us look in this figure, that light is coming from this medium, it is going to the second medium, and some mirror is placed at this place. Then since the mirror has a quality to reflect back, so light will reflect back and will follow the same path. It will reverse the path. This is known as the principle of reversibility. So the principle states that if the final path of the ray of the light after it has been reflected, then it will refollow or retraces its path. It will retrace its path. Now refractive index n2 with respect to 1, that is sin I upon sin R. So refractive index, this is the second medium and this is the first medium. I is in the first medium and R is in the second medium. So refractive index of the second medium with respect to 1 is equal to sin I upon sin R. Or if you write say refractive index of the first medium with respect to 2, then it will be sin R upon sin I. If you multiply these two equations, this one and this one, what you will get? The result is 1. So you can say that refractive index of water with respect to air is known 4/3, or refractive index of air with respect to water is 3/4. So it retraces its path. Now refraction through multiple surfaces. Now if we have the three surfaces, that is the air, water, glass, and then again air. So first the light will travel from air, it bends to water. Water is denser than air, so it will bend towards the normal. Then it is passing from water to glass. Glass is denser than water, so again it bends towards the normal. From glass it comes into air, so it bends away from the normal. Now here we will see that the light is traveling to the multiple surfaces, that is air, water, glass, but the final medium is again air. So the final ray of light and the initial ray of light, they will parallel to each other. Now, refractive index of water with respect to air, as the ray of light is traveling from first medium to another. So we can write refractive index of water with respect to air, that is sin I upon sin R1. Similarly, in the second medium, it is going from water to glass. So we can say refractive index of glass with respect to water is sin R1 upon sin R2. Look here carefully. Then रिफ्रैक्टिव इंडेक्स ऑफ एयर विद रिस्पेक्ट टू ग्लास, इन दोनों इक्वेशन से यहाँ से आप लिख सकते हैं साइन R2 अपॉन साइन R1. So if you multiply these three equations, on the right hand side what you will get is equal to 1, and on left hand side, that is mu of water with respect to air, mu of glass with respect to water, and mu of air with respect to glass. So from here you can reduce it, that is mu of water with respect to air into mu of glass with respect to water is equal to mu of glass with respect to air. That is, the relation is like this. So using this relation you can find out, or you can solve the different questions. Now let us solve one question here, that is refractive index of glass with respect to air is given 3/2, and refractive index of water with respect to air is given 4/3. Here we have to find the refractive index of glass with water, that is mu of glass with air is 3/2 and mu of water with respect to 4/3, and mu of glass of water we have to find. So from this relation we can have mu of water with respect to air into mu of glass with respect to water is equal to mu of glass with respect to air. So by putting the values over here we can find out that mu of glass with respect to mu of glass with respect to water is 9/8. So that is all for today's lecture.